Hey, good morning, everybody. This is Mr. Ainsworth, and we are going to get into part two here in section two in our modern math or discrete class here. And we're going to be talking about linear growth arithmetic sums, which are series. Okay, so basically, we're going to take our techniques from last section dealing with arithmetic sequences, and we're going to sum up the terms. Okay, we call those series. All right, so here's a little teaser for you guys. All right, so check this out. I want you guys to add all the numbers from 1 through 10 first. Okay, seems pretty elementary, but I want you to do it. Okay, so sum means add all the numbers from 1 to 10. So 1 plus 2 plus 3 plus 4 plus 5, 6, 7, 8 plus 9 plus 10. Okay, go. Add them all up, write a number down. Okay. All right, so let me see. If you just add them up mentally, you got 1 plus 2 is 3, plus 3 is 6, 14, 15, 21, 28, 36, 45, 55, 55. Okay, if you want to check, you just go ahead and check. All right, you can do this. And uh, as long as you press them in correctly, which I did not, let me just fix that. You should get 55. Okay, 55. All right, that was really mind-wrenching. Okay, let's try something even harder. Okay, I want you to sum all the numbers up from 1 to 20. Okay, go. All right, 1 plus 2 plus 3 plus 4 plus dot, 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 plus 18 plus 19 plus 20. All right, go. Add up all the numbers from 1 to 20. All right, and throw a number down there. What's taking you so long? Come on, guys. 1 plus 2 plus 3, all the way up to 20. Well, believe it or not, if you work it out, okay, and I'm not going to do this on the calculator, you get 210. All right, which is not too hard. Everybody can do that, and especially with a calculator. I mean, I just gave you like 30 seconds and you can come up with 210. Most people can do it in under 60 seconds. All right, but how about this? How about I want you to sum all the numbers from 1 to 1,000, okay? So 1 plus 2 plus 3 plus 4 plus dot 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 plus 998 plus 999 plus 1,000. Okay, what in the world does that equal to? All right, that's the part of the goal of this section, okay? Guys, I'm not going to tell you what that is right now, all right? But we will later on. All right, but let me start by telling you a story about Johann Carl Friedrich Gauss, okay? You're looking at him right now. Say hi to Gauss. All right. He was back in the 19th century. He lived from 1771 to 1855, and he was just a young stud as a mathematician. Actually, not in his early years. Actually, they thought he was not very good at all up until one fateful day when he was really, really young. As the story goes, his instructor, Mr. Butner, okay, asked the class to add all the numbers from 1 to 100. Okay, I just asked you 1 to 1,000. He just asked 1 to 100. Now, granted, he was pretty young. All right. He, I guess, wanted to buy some time. So he asked his class to add the numbers from 1 to 100. And within just a short, very short period of time, Gauss immediately wrote down his answer and gave it to the teacher. And he said, Whoa. He looked at him and said, I have nothing left to teach you. That's how the story goes. And because he was right, he got the correct answer. All right. And so the question is, how in the world did Gauss come up with the answer, which is the sum of the numbers 1 through 100 so quickly when his classmates, all right, couldn't even produce it, not even in a short period of time, but couldn't even produce it at all. All right. And so the answer is, I'm not going to say the method, but the answer basically is that he got creative. All right. He solved it using his creativity. All right, and that's what we want to do. We want to take a look at how he approached this problem back. Ooh, look at this. Back in, well, he was from 1777 to 1855, so basically the 19th century, right there. And he was like 5 years old, so it was like 1782 when he did this, okay, which is pretty darn amazing. All right, but he got it creative. And so this is what he probably thought of. And I don't know if this is totally true, although this is what the history books say. All right. But he thought of the numbers 1 plus 2 plus 3 plus 4. And so work with me here all the way up to 100. Okay. So he was thinking about this. And of course, he didn't write them all down, but he wrote a few here and dot, 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 dot. And he wrote a few in the middle. Okay. 49. All right. 50, 51 plus 52 plus dot, dot, dot. There's a lot of numbers missing here. I'm not going to write them all. Plus all the way to 98 plus 99 plus 100. So he wrote down a few numbers here and then he said, well, we got to sum them up. So how can you do it in a more creative fashion? All right, so make it a lot easier because there's 100 numbers here that you got to add. All right, so he thought of pairing up the numbers. So he took 1 and paired it up with 100. Okay, so 1 plus 100 is 101. So 1 plus 100 is 101. And then he paired up 2. Whoop, a little crazy right there. Let me back up a little bit here. Okay, there we go. Paired up 2 with 99. And notice that 2 and 99, guess what? It's 101. And then he paired up 3 with 98 right here. And guess what? 3 plus 98. Oh, how about that? It's 101 as well. And he kept on doing this, and you notice there's a specific pattern. And then here he paired up 49 and 52. So 49 plus 52, well, guess what? That's 40 and 50 is 90 plus 11, that's 101. Oh my gosh, there's a pattern here. And then the two numbers in the middle here, 50 plus 51, the two innermost numbers, they add up to 101 as well. So then all he had to do is he had to ask himself this simple question is how many, all right, pairs of numbers or pairs sum up to, or pairs of numbers, all right, sum, which means add, right? Add sum to or add to 101. So how many? All right, and let me see, if you have 100 numbers total and you're pairing up every single, two numbers in within 1 to 100, how many pairs are there? And hopefully it's obvious that you take 100 and divide it by 2 and you come up with 50 pairs. There are 50 pairs which sum, all right, to 101. And because he knows that, he can figure out the sum pretty easily. So the sum, total sum, let me see, there's 50 pairs and they add up to 101, right? So all he had to do was take 50 times 101 or 101. That's 50 times 100 or 5,000 plus 50 times 1 or 50. So this is equal to 5,050. You can check it on the calculator if you like. So you take 50 times 101 or 101 and you get 5,050. You can type in all these numbers and you can get 5,050, but that's a long way. And the probability that you make an error on the calculator is pretty darn high, guys, because, you've seen me make a mistake on a calculator many times. All right. Even though we could do the math, to get our fingers to do the right thing on the calculator is a challenge sometimes. All right. So you got to get creative. That is the key. One of the keys in mathematics. That's what separates great mathematicians from mediocre, is their level of creativity. All right, it is said that Einstein didn't even write down anything when he was developing the theory of relativity. I'm talking about equals mc squared. He didn't write anything down for at least 3 or 4 years. And then after he's got his thoughts straight, then he started writing things down and came up with it. You got to get creative, and that's what Einstein was great at. That's what Gauss was great at. And that's what you need to be great at, okay? You got to get creative. Okay. There is another way too as well to figure this out. I'm going to share it with you because it leads to the way that Gauss did it and our formula that we use to sum up any number of numbers. Okay, so I'm going to show you another way. So follow me with this. Okay, so what we're going to do is we're going to write out the numbers 1 to 100 again. All right, not all of them, of course. All right, so 1 plus 2 plus 3 plus 4 plus dot, 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 dot. Okay, plus 98 plus 99 plus 100. Just work with me here. Okay, now we're going to rewrite the series backwards. Okay, and you'll see why we do that in a minute. So rewrite. This is called a series now. When you add up a bunch of numbers here, it's called a series. Rewrite the series backwards. All right, so 100 plus 99 plus 98 plus 97 plus dot 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 dot. Okay, plus 3 plus 2 plus 1. All right, so let's do that. Okay. Okay. And now what we're going to do is add them. Okay, put a big plus sign. All right, we're going to add them. We're going to add these two series. So basically, we're going to be double counting. Okay. So when we add these, okay, so check this out. 1 plus 101, excuse me, 1 plus 100 is 101. And then 2 plus 99, that's 101. And then 3 plus 98, that's 101. And then you got 4 plus 97, that's 101 too. Well, you keep on doing this, okay? That's 101. That's 101. That's 101. So if you add these pairs of numbers, so you get 101 each time in each pair of sums here, okay? And guess what? When you got to count all these, there's 100 of them, right? I mean, 1 to a number, there's 100 numbers, right? So there's 100 of them. So in order to get the total sum, it's pretty simple. All right, it takes 100. We got 100 of them, so we got to take 101. If we got 100 of them, we got to multiply it by 100, right? Okay, and that gives us our total sum. However, we double counted. This right here, all these right here, that's double counting. We're double counting, okay? Double counted. All right, and obviously we're going to get twice as much as what we want, right? So what do we have to do? Well, we have to divide this sum by 2 because of the fact that we double counted. We only want the numbers from 1 to 100, the sum, that is. All right, so if you add twice as much, then you got to take the result and divide it by 2. Okay, so what do we have here? What do we have? Well, let's figure this out. Let's do it on the calculator first. 101 times 100, all right, divided by 2. Oh my gosh, we got that 5,050 again. And then if you look a little bit deeper here, if you compare, let's say this right here with what we have here, it's basically the same thing because 100 divided by 2 is 50. And you'll notice right here, 101 times 50. It's the same thing. So what Gauss did is a very, very similar thing. But I did it this way because I want you to see what's going on. Okay, right here, this number here, we're going to label a little bit here. The 100 right here, that's your last term in the series, right? And the 1 right here, this 1 right here, that is your first term. So 100 was the last term in our series. Remember, a series is just a sum of a bunch of numbers right here. 1 is the first term, 100 is the last term, and if you take 100 plus 1, okay, you get 101. So really, I can translate this formula in the following way, okay? The sum of the first, right, n, quote that, all right, terms, we're going to give that a special notation, big S for sum, all right? That's what the big S stands for, summation, okay? S stands for summation. All right, and sub n, meaning that it's the summation of the first n terms. Okay, first 50 terms, first 100 terms, however many there is, right? So n stands for the number of terms you're adding. In this case, there's 100 of them. All right, it's going to be equal to, all right, this 101, but where did we get it? Well, we took the first and the last terms and added them together, right? So first plus last times 100. Well, what does 100 stand for? Well, it's the number of terms. So times the number of terms that you're adding, all divided by 2. Okay, it's the first plus the last divided by 2. Okay, and that's how I remember the formula here. When I add up any number of terms, I don't care whether it's 50 terms, 1,000 terms, a million terms, I always take first plus last times n, all right, divided by 2. All right, and that right there is our main formula of the entire part 2 in the section 2 here. Okay, so we should probably highlight this baby because this right here is our big gun. Okay, this is our summation formula for arithmetic series. Let's note that. Okay, for arithmetic series. All right, not geometric, but arithmetic. Geometric comes in section 3. All right, so we'll talk about that later. But for arithmetic series, it's first times last times the number of terms divided by 2. So pause the video and say that to your buddy next to you. All right, hopefully that made you laugh. All right, so let's go ahead and apply it. Let's go ahead and take a look at a real problem here. All right, so in this one here, the arithmetic sum formula example problem. Okay, so a small tractor manufacturer has a 12-week production schedule for its radically new 2008 model. Ooh. The plan is to manufacture 3 additional tractors each week. That's obviously important, so let's underline that right there. 3 additional tractors per week. All right, for the next 12 weeks for the original, from the original 10 produced. Ooh, okay, from the original 10 produced. Sounds like that's a starting amount. Okay, these tractors are stored in several warehouses until the release date. If the storage costs $10 per tractor per week, that's obviously important there. Okay, so let me underline that. Storage cost, $10 per tractor per week. What will the total storage cost be? Total storage cost of the company be over the 12-week period. That's total. That means sum of all the cost over the weeks. Sum of all the costs. All the costs, or the weekly costs. Okay? So, how do we do that? Well, let's think about it here, okay? So it's $10 per tractor per week. We're adding 3 additional tractors each week. Well, let's translate that. So 3 tractors, okay, per week. WK is week. All right. Now, each tractor costs $10. It costs $10 per tractor per week. So we have to multiply this by $10. All right, to get the weekly cost. So 3 times 10, well, that's $30. All right, per week. That's a weekly cost. Okay, and let's see if we understand that. 3 additional tractors each week. Each one costs $10 per week. So 3 times 10, look at this right here. It's tough math right here. 3 times 10 is $30 per week for those 3 tractors. All right. Let me see. Let's go back to reading it. So from the original 10 they produced, the original 10 that they produced. Okay, now if they produce 10, you got to store those guys too. So let's take this right here and let's bring it off to the side. If they got to store the 10 and it costs $10 per. It says right here $10 per tractor per week, right? So 10 times 10, ooh, is $100. All right, cost. That's this right here, guys, okay? This is where we start. Okay, that's the starting cost, or what we call the seed. Okay, now what's going on here? Every week we make 3 additional tractors, okay? Well, not make. Well, yeah, they make and then they got to store them, right? After you make it, you got to store it. You got to put it in a warehouse. But it's $10 per tractor, so that's why we multiply 3 times 10. So what we need to do is we have to add $30 every week, so plus $30, dollar sign, right? Plus $30, plus $30 here. So 100 plus 30 is $130 after the first week. Piece of 1 stands for after 1 week, or the cost after 1 week. Total cost, that is. Okay, what's the cost after 2 weeks? and so on. So we have to keep adding $30 because every week we make 3 additional tractors and we got to store them at $10 per tractor, right? So we have to add $30 more. So it's $160 after 2 weeks, right? And then we got to keep adding 30. 160 plus 30 is 190 after 3 weeks. And then plus 30, you get the idea. 190 plus 30 is 220. All right, if you can't follow the math in your head, just use a calculator and keep on adding 30. And the question is, what does it cost after 11 weeks? And notice that didn't leave that in there because sometimes you don't want to list them all, right? Especially if I ask you way out in the future, you got to calculate it, right? So let's use a little function here. P sub n is the seed. Let's get smart. Let's use the techniques from last section. All right, plus d times n, right? We know that from prior lessons. Well, the seed's 100, so P sub n is equal to 100 plus d, the common difference, or what we add, which is this right here. This is d, right? The common difference, so plus 30n. There's our explicit function. Okay, so I'm using prior knowledge, right? I use an explicit function that we already know for arithmetic sequences, and I apply it. And this is what helps me predict the future because I need to know what P sub 11 is without listing them all, right? So let's figure that out. So P sub 11 is equal to 100 plus 30 times 11. That's 330 plus 100, or $430. But if you didn't get it quite that fast, you go 30. Let me start over here. Let's go 100 plus 30 times 11. You should get 430. So good. So $430 in the 11th week, or after 11 transitions or 11 weeks. Okay, remember this is a cost to store the tractors. Okay, and then you have to add 30 more. So after 12 weeks, okay, there's $460 for storage costs. This is a storage cost. Storage cost. All right. So that's what the cost is over time. All right. And the question is, what is the total cost? I mean, if you add up all these numbers, this one plus this one plus this one plus all these plus dot 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 plus this one plus this one, what's the total? All right. What is the total? We want to know the total sum. That's what I asked right here, the total storage cost. Go back and read the problem. What is the total storage cost over the 12-week period? That means you have to add up all these costs together. The question is, what is it, right? Because we didn't list them all. We left out weeks 5 through 10. All right, so let's get real smart here. Okay, so we understand that the total storage cost is equal to 100 plus 130 plus 430 plus all the way to 460. The question is, what is that big number there, right? So what we're going to do is we're going to do what we did before. All right, so we write the sum twice, and once forward, once backwards, once forward, and then once backwards, and then line them up and add. So let's try that. Okay, so 100 plus 130 plus 160, excuse me, plus dot 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 dot, plus 430 plus 460. Oops, right there. Now let's write it backwards. 460 plus 430 plus 400 plus dot 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 dot. Okay, plus 130 plus 100. All right, and then we add them up. And so what do we get? The total sum. Let me see here. We add these up right here, right? We get 560. This is 560 right here. We get 560 here plus, another 560 plus another 560 plus dot dot dot. This one, 560 again, plus this one, 560 again. And again, how many of these do we have? Well, from week 1 to week 12, there's 12 weeks, plus the start amount. So how many terms do we have? Do we have 12 or do we have one more? And the answer is we have one more than 12 because we start counting at 0. So from 0 to 12, you just got to look at right here. There's 12 terms here, all right, plus the seed, right? So 12 plus 1 is 13. So if you count from 0 to 12, there's 13 terms. So in this problem here, there's actually 13 of these that we're adding. There's 13 of these, 13 terms. So what we need to do is take 560 times 13 and divide it by 2. So our total sum is 560 times 13 divided by 2. Why do we divide by 2? It's because we double counted. All right, remember that. So this right here, we double counted because I listed it twice, right? And so we don't want twice as much, so we got to take the total sum and divide it by 2. Okay, so let's do that. Let's take 560 times 13 divided by 2. You get $3,640. So $3,640. Okay, now you got to remember, what does this really represent? Well, it represents this 560 right here. How did we get this? Well, we took our first term, which is right here, and we took our last term, which is right here. We took our first and our last. This is first plus last times the number of terms, and then we divide it by 2. So one more time, the formula works. The first plus last times the number of terms divided by 2. Okay? And that's how I handle any summation problem when it comes to arithmetic sequences. I take the first term, which is right here. I take the last term, which is right here. All right, I add them up, times it by how many terms I have, and divide that by 2 every single time. Okay, so initially here, or what we have here, this is our last, this term here. This is our first term, the seed. So when you want to add these up, and there's n of them, okay, n terms here, we take first plus last, multiply it by the number of terms, and take that result and always divide by 2 because of the double counting. Okay, and that is the main idea, and that's what we want to get used to, is define the sum. This is equal to a sum now, a sum of n terms. Is you want to get the idea that you just take the first plus last times the number of terms divided by 2 every single time. And you just got to get a little practice. And now, of course, there's different variations of this problem here, so you obviously have to solve a lot of problems and get familiar with it because it's not always straightforward. Sometimes you're not given the last term. Sometimes you're not given the number of terms, and you got to figure out this stuff. So you got to use your head. It's not always straightforward. Okay, so don't think it's always that simple. All right, you got to think a little bit. So in these practice problems here, we want to be able to find the sum. So I'm going to write it down up here again, the sum. All right, S sub n. Everybody say S sub n. Okay, S stands for summation, N stands for the number of terms. All right, this is going to be equal to first plus last times the number of terms, which is n in general, all right, divided by 2. Let's keep that up at the very top. Okay, so let's analyze what's going on. We got a seed here, all right, which is our first term. P sub 100 is 1725. This is your last term. This is saying here you want to add up, all right? This is S, all right? The sum of how many terms? Well, from P sub 0 to 100, you got to figure out how many terms there are from 0 to 100. Well, 0 to 100. Let's think about this. From here to here, from 1 to 100, there's 100 terms. And then you add the seed right here. So you have 100 terms here plus one more for the seed. Okay, well, guess what? There's 101 terms. So when you add p sub 0 to p100 right here, aha, we have 101 terms. That's n. All right, so let's get started here. So the sum of 101 terms, s sub 101, all right, is equal to the first term, 25, plus the last term, 1725, not times 100, which is deceiving, all right? You're counting all the numbers from 0 to 100, okay? This p sub 0 is the first term, not p sub 1, p sub 0 is because we start counting at 0 here, all the way to p100, or p sub 100. All right, there's 101 terms there, so you got to multiply by 101, all right, and divide that by 2. Well, let's do it. So you get 25 plus 1725. You can use parentheses on your calculator if you like, times 101 divided by 2. If you want to use parentheses, go ahead. So quantity, 25 plus 1725, and quantity, times 101 divided by 2. You should get the same value, 88,375. Okay, and that is the sum of the first, or of all 101 terms. The most common mistake people make is that they multiply it by 100 and divide by 2 because they look at p sub 100 here and they think there's 100 terms. There's not. You're counting from 0 all the way to 100. And when you count from 0 to 100, guys, there's 101 terms. You got to understand that, okay? Because you start counting at 0, not 1. Use your common sense. Okay, so let's get used to that. On this one here, p sub 0 is the seed. All right, it's the first term. This is your last term, p sub 20 here. Remember, when you count from 0 to 20, all right, there's 21 terms. That's the first one. That's n. So sum s of 21, the sum of the first 21 terms, is 700 plus the last one, 560. Not times 20. No. 21. Divide that by 2. All right. There's 21 terms there. You can list them all out and you count them up. There's 21 populations right there starting with the seed. So on this one here, we take quantity, 700. Let me start over. Quantity, 700 plus 560. Make sure you use parentheses correctly. Times 21 divided by 2. 13,230. Got to write it down correctly here. Let me double check my calculator. Yes, okay. Okay, let's get some more experience. Okay, we got the first term here, or the seed. We got the last term here. But when you count from 0 to 13, all right, there's 14 terms. All right, and that's n. So s of 14 is equal to 5 plus 70, first plus last, times the number of terms, divide that by 2. All right, so 5, let's clear that out. 5 plus 70, 75. Do that in your head. So 75 times 14 divided by 2. And you should get 525. So it's not too bad when they give you all the information you need, with the exception of n. Yeah, I mean, you have to think a little bit here. You got to figure out how many terms you have. All right, it's pretty straightforward, right? But what happens if you don't know the last term? Let's talk about that. Okay, so here we want to find the sum again. Okay, that's great. But here you know the first term. Look at this. The first term here, you know the common difference. Aha. All right, but you don't know the last term. The last term is this one, p sub 999. You don't know what it is. You know what? The first term, you don't even know what the first term is. Sorry about that. This is the first term. All right, you know this. You know p sub 0 way back in time, right? But you don't know p sub 100. You don't know p sub 999. You don't know either one. Oh my goodness, what do you do? What do you do? What do you do? Okay, so what we're going to have to do is we're going to have to get smart. All right, we're going to have to figure them out. We need to know p sub 100. We need to know p sub 999. We also need to know the explicit function in order to find them. So before we do that, let's find the explicit function. So p sub n is equal to the seed plus d times n. This is from uh, last section, right? So we know this. Ooh, this sounds powerful. We know this, all right? Last section. These are arithmetic sequences, all right? Look at your notes. We know this. So let's figure out, let's write the explicit function here. So the C is 23 plus the common difference is 7 times n. So there's your explicit function. Okay, let's use that. Let's find the piece of 100 or the population after 100 transitions. So 23 plus 7 times 100. All right, we just substitute it in. Once you see n, you just plug it in. See, look at that, piece of cake, right? And let's figure it out. 700 plus 23. Ooh, this is hard stuff. 723. Piece of 999. That's equal to 23 plus 7 times 999, which is 1,000 minus 7, if you care to know. But that's all right. We'll use our calculator. So 999 times 7. All right. Minus plus 23. So we got 7,000. 16. Okay, so 7,016. All right, so here we go. So this is our first term. This is our last term. And now we find the sum. How many terms are there from here? How many terms are there from 100 to 999? So we got to count that. So from 100 to 999, how many numbers are there? Well, let's simplify the problem first, okay? Let's count the numbers from, let's say, 1 to 5, and let's figure this out. Is it easy as subtracting? Is there 999 minus 100, which is 899 terms? That's the most common mistake made, okay? But so let's simplify it. If I take a simpler problem, how many numbers are there from 1 to 5? Okay, so 1 to 5. So 1, 2, 3, 4, 5, right? If you take 5 minus 1, you get 4. But how many numbers are there? Well, 1, 2, 3, 4, 5. There's 5 numbers, right? So if you subtract 5 minus 1, like people want to do here, you're going to get 1 less than you're looking for. 5 minus 1 is 4, but that's 1 less than the number of numbers in a list from whatever to whatever. So subtraction works, but you got to add 1 to do that. So what we need to do is take 999, subtract 100, well, that's 899, and then add 1. There's actually 900 terms. Okay? So there's 900 terms. So really what we want to do is find S sub 900. So what we're going to do is we're going to take the first term, which is 723. Okay, we're going to take these two guys. These two. All right, 723 plus 7,016. Multiply it by 900, and then divide that by 2. Piece of cake. All right, as long as you have a calculator. All right, so let's do it. So 723 plus 7,016. Got to multiply it times 900 divided by 2. You can use parentheses too if you want. All right, so what you get is 3,482,550. Let me verify that. Looking good. All right, and that is the sum of the 900 terms. Okay, total sum of 900 terms from p sub 100 all the way to p sub 999. Whew, that's a lot, okay? That's a big number, guys. Wouldn't be possible, by the way, if you didn't have this formula, because there's too many of them, okay? Just take first plus last times n, the number of terms, divided by 2. Easy. Okay? This one's very, very similar. The question is, when from 100 to 199, how many terms are there? So what you do is you subtract and add 1. So 199 minus 100 equals 99 plus 1 more. There's 100 terms. Okay? So the only thing we need to do, like on the previous one here, is we got to figure out what this is and what this is. So let's figure them out. So we write explicit function first. So 23 plus 7n. There's my explicit function. Just plug in your seed and your common difference. Find piece of 100. 23 plus 7 times 100. 723. Piece of 199. 23 plus 7 times 199. So 7 times 199 plus 23 more. 1416. So S sub 100, there's 100 terms now, right? There's 100 terms. That's equal to first plus last divided by 2. So 723 plus 1416 times how many terms divided by 2. And if you do the arithmetic here, let's see. So 723 times 1416. Oops, I don't want to divide. I want to multiply times 100 divided by 2. I didn't do that correctly, did I? Let's see. No, I didn't. Okay, let's start it over. Incorrect input is incorrect output. So 723 plus 1416 times 100 divided by 2. Let's do it right. That's more like it. 106,950. Okay? So if you're not given the first and the last term, you got to write your explicit function first, like I did. All right? You got to write it, all right, and then use it. All right, this is used to find these two things here, the first and the last terms. First term, last term, and then substitute it in. You got your first term here, and you got your last term here. First plus last times n, all right, divided by 2. I've only said that probably about, I don't know, 30 times already in this video. So all you have to do is just get good at it. All right. Okay, and I tell you what, I'm going to stop here. This is part 1 of this video here for arithmetic sums, and I'll finish the lesson here in my second portion of the video. So if you need the second portion, you can go right to it. It's on my website, or just look at your Remind. I send out all my hyperlinks to my videos. Just look for 10-2 Linear Growth Arithmetic Series, part 2, and you'll get this second half of the video. In the meantime, what you guys can do is start your homework, which is not on this page, and it's not on the next page, but it's on page 14. Ooh, how about page 15, actually? It's right here. You can start this, okay? And it's on the next page. So do your homework here, and then check your homework with me, with my solutions, that is. And make sure when you do all this, you have to show all work, which means you have to show, this is work here, you have to show all your steps. I send out my solutions, all right, and I don't want to see you guys just write down a bunch of answers, okay? I'm not going to accept that. You have to step it out just like I do in my lesson for any credit here. You got to show me that you actually understand and know how to produce the answers. So when you do your homework, do a good job. It has to look like this, okay? Otherwise, I will not accept it. All right, so do your best, and then, I got to tell you which ones to do. You can start your homework, you can do 10 through 12, okay? So on this portion of the lesson, you should be able to do 10, 11, and 12, and then you should be able to do those, and then check my answers later on when I send them out. Check my answers with yours, check your answers with mine, however you want to say it. And then, of course, look for part 2 video here to finish the techniques that are used to solve all summation problems dealing with arithmetic sequences. So I'll start right here on my part 2 of the video. Okay, this is Mr. Ainsworth. I'm signing out, man. I'm getting a little tired. I'm going to take a break, and I'll see you in my next lesson. Bye-bye.